Good morning, everyone. In our last videos, we started a new batch for this data structures and algorithms with Java. The timings of this batch is from 9:30 to 10:30. Okay, 9:30 to 10:30. Okay, and so the duration of this course is 2 months. Within 2 months, we are going to finish this course, and the fees for this batch is rupees 999. Offer fee rupees 999. So if you want to get registered for this course, you can contact to these numbers like 720-721-2427, or you can contact to our online team DURGASOFT online training at gmail.com. And the code of this batch is DSA JB5, fifth batch. And the syllabus, what we are going to discuss here is introduction to DSA, and how you can able to prepare some sample algorithms, how you can go for implementations, and array related programs, matrix programs, CRUD operations on arrays, string data structure, how to handle the string programs, CRUD operations on strings, recursion and its applications, sorting and searching, list data structure, stack data structure, queue data structure, hash table data structure, tree data structure, priority queues and heap data structure, graph data structure, divide and conquer algorithms, dynamic programming, backtracking, greedy method, and what are the various complexities, time and space complexities, what are the notations that we are using, okay, and how we can calculate a time and space complexities, and what is mean by bit manipulation. All these things we are going to discuss. And the persons who have not attended the last two demo classes, so I'm going to share that video. Okay, you can cross check. So in this playlist, we have previous two classes demos are uploaded, and even today's video also they are going to upload within few minutes, okay, in the YouTube. And in the yesterday, we have seen how to create a class in Java and how to create object in Java. And what is toString method? What is the purpose of toString method? How we can able to override that toString method also we discussed very clearly. Okay. And even we have seen swapping of two numbers also. That application I covered very clearly in our last session, sir. Okay. Now, in today's session, as a part of continuation for this, no, Sarath Babu, we are not going to cover on that. Okay, sir, in our last video, we discussed about swapping of two numbers, how you can able to interchange the values. So if you are giving two numbers like A is equal to 10, B is equal to 20, we need to write a logic so that it has to interchange those two values. So after performing this interchange operation, your A value should be 20, and your B value should be 10. Like that we have to do. So how you can able to work with that, we are going to discuss now. So there are totally 5 logics are there. Totally 5 logics are there for implementing this program. What is the first logic? By using temporary variable, how we can able to solve. Second one, by using addition and subtraction, how you can able to do. And by using multiplication and division, how you can able to do. And by using single line statement, how you can work. Even by using bitwise operators, how you can do that. These things we are going to discuss in our today's session. Already I explained logic 1, right? What is the logic 1? By using temporary variable, how we can able to swap. Very simple here. So we are going to take temporary variable. Suppose if you take the initial value of A is equal to 10 and the initial value of B is equal to 20 means, so first we are going to store this A value in temp. Then so A value is copied with B value, that is 20, and B value already that A value we have stored in temp, right? That we are going to copy. So the initial value of A and B will be 10, 20. So after swapping, the value of A and B got interchanged 20, 10. I want to implement this process. how we can able to do. Let us take a simple Java program to perform this activity. Okay. Today morning, I have taken binary search tree. In that, I explained how to find out maximum element once again. So how to create a binary search tree? What is the structure of that binary search tree? So next and after that, how to create a binary tree, in order traversal, insertion of a new node into binary search tree, how to find minimum element present in the binary search tree, how to find out a maximum element, is the given tree is a binary tree or not, and how to perform delete operation, how to find in order successor. These operations we explained for in the morning session, that's 7 o'clock. Okay, right, sir. Now I need to implement this swapping, sir. I need to implement this swapping. So I want to go for, so one special method I need to define, or one special class I want to take. That class is nothing but a demo class. Okay, I'm defining one method. So public static void, okay, sir, swapping of two numbers, and I am taking logic one, which is receiving two variables, a and then b, like this we have. Now my requirement is, I want to print the value of a and b at very beginning. So system dot out dot println of, I can say, before swapping. Okay, before swapping, what is the value of a and what is the value of b? These two values I want to print on the screen. Anyway, I will do swapping. After doing that swapping, how to do that swapping? We need to take one temporary variable, and we are going to store the value of a in that temporary and b value into a, and then b is equal to temp. That's all. So now here the message which I am taking is nothing but after swapping. Sir, how you can able to call this? We have to call this function by taking demo dot, so swap logic one. So I'm passing 10 and then 20. I'm passing 10 and then 20. Sir, this is logic one, right? So let us print that interface message also. I am printing, sir, swapping logic one I am taking. Okay, so it is taking these two numbers, and before performing swapping operation, what is the value of a and b, and after performing swapping operation, what is the value of a and b we are printing. Sir, even we can reverse, we can write in the reverse, but that is not my intention. Internal values should be reversed. Okay, so now I want to execute this code. Let us see how we can able to do that. So py space, sorry, not py, it is Java, right? So Java C space test.java. I'm trying to compile my Java code. There is no error in the program. Now I want to run the Java code. As you can see, so swapping logic. Before performing swapping operation, my A value is a 10, B value is a 20. After performing swapping operation, my A value is a 20 and B value is a 10. Like this we have, my A value is nothing but a 20 and B value is nothing but a 10. Like this we have. This is the way how we can swap by using logic one. I think in the yesterday itself, I explained very clearly about this logic, sir. Can you please confirm everyone, is this logic is clear for you people?
Yes, sir.
Yes, sir.
Right. So someone is asking, sir, can you please use Eclipse so that we can understand more clearly? No. If we are using Eclipse, we will become very lazy when the problem is very complex. In such cases, we are not going to concentrate on syntaxes. In such cases, we have to go for Eclipse. The reason for that is, for example, if I am taking demo dot, in the demo class, what methods are there? Automatically, it will list out. So at a very beginning stage, we are not that much lazy. That's why you need to see in detail the language concepts, means better to go with normal IDEs itself. So in my classes for linked list, I'm going to take what you can call Eclipse IDE, because in the linked list, so many operations we are going to involve. like some 20 to 30 methods we will take. So some variables will be there, object creation. There I will concentrate on the concept rather than syntaxes. But these problems are small problems, right? Here we can concentrate on problems as well as syntaxes. That's why, so my style of taking the classes is nothing but only with this edit plus or something like these editors. Okay, I will never recommend my students to do the problems in Eclipse or NetBeans or IntelliJ like that. So only few things we can do that in our complete syllabus. Maybe for trees, graphs, linked list, for these three the problems are very complex. That's why we are going to take Eclipse. Okay, Sarath. No, so Sivakumar. Right. Sir, what is the second logic here? So by using addition and subtraction, how we can able to calculate? By using addition and subtraction, how you can do swapping, sir? Very simple. For this, we have some predefined, we have some formulas are there. By using that, we can able to do. Okay, one second. Yeah. So just give me 1 minute time, sir. I will be back. Please wait for 1 minute. Yeah, right. Sorry. Welcome back. So let us see this second logic. What is this second logic? Sir, by using by using addition and subtraction also, we can swap two numbers. Sir, how we can able to do that? Very simple. Here we have some special logic is there. Like A is equal to A plus B. So B is equal to A minus B. A is equal to A minus B. Like this we can take. Let us take example here. First, I will explain this process. So what is this second process here? By using addition and subtraction. For understanding purpose, I am taking, so the value of A is equal to 2 and the value of a B is equal to 3. Like this we have. So what is the first instruction? A is equal to A plus B. Okay. So this is nothing but memory location for A, and this is nothing but memory location for B. Now, what is the value of A initially 2? What is the value of B initially 3? A is equal to, we are calculating addition of these two. A plus B, 2 plus 3 will become 5. I am going to store it in A. So A value got updated to 5. Now B is equal to A minus B. What is the latest value of A? 5. Minus what is the latest value of B? 3. So 5 minus 3 will become 2. So you have to update B with 2. Now A is equal to again A minus B. What is the value, latest value of A? 5. Minus what is the latest value of B? 2. 5 minus 2 will become 3. So your A value will become 3. Like this we have. Okay. So this is nothing but what is the A value here? We are getting 3, and what is the B value here? We are getting 2. So like this, we can swap two integer values by using this addition and subtraction logic. Sir, if you are clear with this logic, I will go to implementing this particular concept. Can you please confirm everyone? Is the concept is clear for you people?
Yes, sir.
Yes, sir.
Yes, requesting everyone to please respond.
Yes, sir.
Right. Now we will see how you can able to implement. So what we need to do here, problem statement is the same. Here I'm going to take swapping logic 2. So here temporary variable is not required. Math formula I am taking A is equal to A plus B, and B is equal to, okay, B is equal to A minus B, and A is equal to, I am taking A minus B. Like this we are going to take. Now, sir, let us call this swapping logic 2. Okay, so swapping logic 2. I am passing the values like 11 and 22. Let me check is that swapping is performed or not. Anyway, first one already we explored. So second one, before swapping, A is equal to 11 and B is equal to 22. After swapping, your A value will become 22 and B value will become 11. So the values got interchanged, right? This is the way how you can swap two numbers by using this addition and subtraction. Sir, now I'm taking logic 3 by using multiplication and division, how we can do. Sir, I already explained in the last video itself. Let us take A value as something like 5 and a B value as 4. Like this I have. So a memory location will be created to hold the content A, and one more memory location is created to hold the content B. Like this we have. So your A value is nothing but 5 and your B value is nothing but 4. What is the first instruction? I am multiplying A and then B, and I am going to store the result in A. 5 into 4 will become 20. I am going to store that 20 inside A. Now I am taking A by B. What is the updated A value? Updated A value is nothing but 20. So by 4 means your result is a 5. That I am updating to B. Now A is equal to, what is the updated A value? 20. So by B value is nothing but 5. Then what answer we are going to get? 4. That I am going to update here. Okay, like this we are going to do swapping of two numbers. Previously A value is a 5. Now A value is 4. Previously B value is 4. Now B value is 5. Sir, the values got interchanged or not? Yes. I want to implement these with a program. How we can able to do? Sir, same thing. I'm going to call swapping logic 3. Swapping logic 3. So where I will pass something like 40 and then 50. So here also we have to implement the method. Like I'm taking swapping logic 3. So before swapping, after swapping, here I'm taking multiplication. So here we have to take division. That's all. Sir, let us see how it is going to execute. Now you can see, sir, before swapping, my logic 3, before swapping, A value 40, B value 50. After swapping, A value 50, B value 40. The values got interchanged or not? Yes, this is the way how we can able to apply. Swapping with logic 3, third logic, that is nothing but by using multiplication and division. Can you please confirm, is these first three logics are clear for you people? Please confirm.
Yes, sir.
Sir,
Yes.
sir, I have one doubt.
Sir, your voice is breaking. Please use chat window. Right. Clear for everyone? Right. Now I want to take the fourth logic. What is the fourth logic? By using single line statement also we can do this. By using single line statement also we can able to use this. Sir, how you can able to write a single line statement? If any one value is 0, then how it works? I think it will work, sir. If any one value is 0, I think it will work. No, it won't work. Suppose a is equal to 2, b is equal to 0. So a is equal to a into b. I think it won't work, right? Let me cross check. So here I'm going to give, in the place of this, I'm taking 0. I think it won't work, right? Because yeah, arithmetic exception. Okay, division by 0. Maybe it is not going to work. Okay, yeah. So but addition and this logic will work and this logic also will work. Yeah, no problem. We have some pros and cons. Okay, right. Next, by using single line statement, how you can do? Sir, a is equal to a plus b minus b is equal to a. This is the single line statement what we can take. Let me explore this. Sir, assume a is equal to 1, b is equal to 2. So what is the statement? A is equal to a plus b, 1 plus 2, 3, minus b is equal to a. So that is 3 minus 1. Your a value will become 2. What is the value of a b? Is equal to 1. Sir, previously a value is 1, b value is 2. Now a value is 2, b value is 1. So let us execute this parallelly, whether it is working or not. So I want to take a swapping logic 4. Swapping logic 4. Let us take, so 50 and 60, like this I am taking. So how many lines of code we have to write here? Only single line logic is sufficient. Yes, what is that? A is equal to a plus b minus b is equal to a. That's all. So first addition and then assignment and then evaluation. Okay, like based on the priority levels, it will calculate, but the elements are going to be swapped. If you want, we can cross check. So logic 4. Before swapping, a is equal to 50 and 60. After swapping, a is equal to 60 and b is equal to 50. You can see here the values got interchanged. We can see here the values got interchanged. This is nothing but fourth logic what we have. Is it clear for you people? Please confirm.
Yes, sir.
Yes, requesting everyone to please respond clear up to this.
Yes, sir.
Yes, sir. Yeah.
Right. So what is the last logic? Logic number 5. By using bitwise operators, how we can able to do? By using bitwise operators, how we can able to do? Very simple. For this, we have 3 instructions are there. All these 3 instructions are having same formula. A is equal to a cap b. So b is equal to a cap b. A is equal to a cap b. Like this we have. Sir, this cap operator, you know very well. So what is a truth table for cap operator? If you have 1 and then 1, and if you have 0 and then 0, in these 2 cases, the result will become 0, sir. Suppose if one bit is 0, second bit is 1. If one bit is 1 and second bit is 0, in these 2 cases, the result is 1. That means after converting it into binary, then we have to look forward this. Now let us take the value of a. I am taking just for example purpose 7. So what is its binary equivalent? So 8421, 84, okay, 21, like this we have. If you take A is equal to 9, sir, what is the binary equivalent? 1001. So these are nothing but binary equivalents what we have. So what is the value of A, sir? So 0111. What is the value of B, sir? 1001. Now, what is the first formula? A is equal to A cap B. So A value, latest value of A is 0311. Latest value of B is 1001. Perform cap operation. 1 or 0, 1, 1, 1, and here we will get 0. What is this value, sir? Latest value of A. Now the latest value of A will become 1111 followed by 0. Now, what is the second formula? B is equal to A cap B. What is the latest value of A? 1110. What is the value of B? 1001. Perform cap operation. This will become 0111. This is nothing but the latest value of B what we have. Now, what is the last formula? A is equal to again A cap B. What is the latest value of A, sir? 1110. What is the latest value of B? 0111. So here we are going to get 1, 0, 0, and then 1. Sir, the latest value of B is 100, 1001. Sorry, not A, not B. It is A, right? Sorry. The latest value of A is nothing but 1001. Have you observed here? The value of A is 0311, but now 0311 went for B. Okay, what is its equivalent? It is a 7. What is its equivalent? It is 9. Previously A is 7, now B is 7. Previously B is 9, now A is 9. Okay, like this, these bitwise operators, by using these bitwise operators, we can write the logic. Can you please confirm, everyone, is the concept is clear for you people? Please confirm, is the concept is clear for everyone? Please confirm.
Yes, sir.
Yes, sir.
Right. Now, so let us see how you can able to execute this. So public static void swapping logic 5. So before swapping, what is the instruction here? A is equal to A cap B. So B is equal to A cap B and A is equal to A cap B. Like this I am taking. And here also we have to execute that. So swapping logic 5 and then logic 5. Here let me give 60 and 7. Now let us execute this code and check how it is working. You can see the values got interchanged or not. Yes, perfectly it is working. Okay, so this is nothing but how you can able to work, sir. Okay, so I think all these 5 logics with executable code, you people got very clear clarity, sir. Can you please confirm any doubts up to this?
Sir, could you please go to one diagram? Yes, sir.
Which diagram, sir?
Uh, diagram bitwise diagram, right? Yes, sir.
Yes.
So in this, like bitwise 10 should be 1, right? Here, when we are calculating like 101, right?
Sir, what is your doubt? Where you are getting confusion?
In the bitwise, right? Sir, 1010.
Which
Left
one?
side. Left side, sir.
This
Yeah,
one?
this one. Yeah.
This is the formula for bitwise operators, sir. In the cap truth table, if both bits are in same direction, the result is 0.
Okay, okay, okay. I thought like okay. I thought like here. Oh yeah, I understood, sir.
Right. Yeah. So fourth logic, sir, in the fourth logic, nothing is there. Just you can trace out A is equal to A plus B. For example, if you have A is equal to 7 and B is equal to 3, what we are doing, A is equal to A plus B, 7 plus 3, 10, minus B is equal to A. What is the A value? A value is 7. Okay, A value is 7. So that I am assigning to B. Now B will become 7. So what is the value of A? It will become 3. Got it?
So can you show that program logic for that bitwise operator? Yeah, here. So here, right, with that cap operator, it will understand that it should take the bitwise.
Yes, yes, because that cap operator is a bitwise operators what we have in our languages.
Okay.
Not only in Java, in every programming language. So these bitwise operators are having some special significances. So clear, everyone?
Yes, sir.
Right. Now, so the next one, what we are going to discuss here is nothing but, sir, I want to go with, okay, I want to go with some linked list related concept, sir. Okay, I want to go with some linked list related concept. Here, why you have taken 2 classes? Can't do within the class method? Any coding safe? No, no, no. We can take anything. We can take within the class. So in this test class itself also we can take. Okay. I think yesterday we have done the programming related to that, right? So just for our normal, we don't have any strategy for that. Sometimes we will take the data from other classes. Sometimes we will define within the class. You can take anything, no issues. Right. So the next one in the demo session, I want to talk about the next concept. So swapping of 2 numbers, all these 5 logics are clear for you. Sir, now I want to explain about how we can able to insert the value at the beginning and at the ending of single linked list. How you can able to add the value at the beginning and ending of single linked list. Sir, now just for your understanding purpose, I am telling. So this is my single linked list what I have. This is my single linked list what I have. Okay. So this is one node and this is another node. Okay. Maybe I am not explaining with the help of code, sir. Please try to understand. So this is nothing but another node. So total, how many nodes are there here? I have 3 nodes are there. Since these are nodes, every node will have, okay, 2 fields will be there. One field is representing the data. Okay, one field is representing the data. Other field is representing a pointer which is pointing to the next node. So here also one pointer will be there which is pointing to the next node. Here we don't have any pointer. I mean, we have pointer which is always pointing to the null because there is no node is there after this 33. That's why it is pointing with null. So this is my single linked list. In the single linked list, the first node name is always head, sir. What is the name of the first node? Always head. We don't have any other pointers in this linked list. Even though your list is having some 100 values, so you are going to point always first location. Okay, you are going to follow always first location. Okay, I mean first location pointer will be there in your hand. That is nothing but head. Now what is my job here? Sir, this is a single linked list. This is a single linked list. So in this single linked list, I want to insert a node at the beginning. At the beginning, I want to insert a new node. How we can able to insert at the beginning, sir? Okay, I want to demonstrate this. Sir, for this, we have to write some logic. Okay, we have to write some logic. But before writing that logic, I will explain the process so that you can understand well. Sir, try to create a new node with some structure. Okay, try to create a new node with some structure. Let us consider the data is 10 and the next field is pointing null, and the name of this node is nothing but new node. Okay, new node like this. I have some node is there. I created a new node like this. Sir, how you can able to work with that? Suppose I need to check some proper condition. Is head is equal to null? What is the meaning of if head is equal to null? We don't have any linked list. If you are not having any linked list, assume this one is not there. Then what will happen? The node which you created will become a node, right? Head node. But already we have some list is there. Then what we have to do? Your newly created node is there, right? Your newly created node is there, right? Sir, its next field you need to point to head node. This is the first operation. Okay, your new node next field should point to head. Then so your new node will become head node. Your new node will become head node, and you have to delete this reference. That's all. This is the simple easy step what we have. So we have some nodes are there. I want to insert a new node at the beginning. What we have to do? Sir, you need to add that node, and that next field link you have to establish with head node. Assume in your classroom 5 students are there. Sir, one new student came. So I need to allocate a proper bench for that student. Sir, where I have to allocate? First, assume I want to allocate first position. Then what we have to do? In the first bench, already some student will be there. Now I am asking, array, you are not first bench student. He will become first bench student. His next student is nothing but you. Like that I am assigning. Very simple. I need to write these in the form of code, and you have to decide whether are you able to understand that code or not. But before writing the code, can you please confirm everyone up to this theoretical knowledge? You got clarity or not? Please confirm.
Yes, sir.
Yes, sir.
Yes, sir.
Please confirm. Everyone, please confirm.
Yes, sir. Sir, one question is here.
Yeah, please go ahead.
Yeah. So there is nothing like the new node 10. And on the initial level, what you showed us 11 with the reference pointer that is holding the next node of 22. Then what is the current pointer of 11?
What is the
current address of the first node?
See, why you are asking address? Actually, this 11 is available. 11 next node is 22. So it is not continuous memory allocation.
Okay.
Like arrays, it is not continuous memory allocation. See, 11 is there somewhere. 22 is there somewhere. We are connecting these two with the link. Are you getting my point? So this is
Yes.
non-linear data structure. There is no continuity. Forget about addresses. Are you getting my point? So
Yes.
11 next node is 22. 22 next node is 33. How we are linking this? By using these symbols. So this is my list actually. In this, I want to add a node at the beginning. How I can able to take? I will create a new node, and maybe just for your understanding purpose, I am taking node here. Maybe that node may be created here itself. You can do that. A node may be created here itself.
Okay.
So suppose if 5 is there, So this will become what? New node. Okay. Now
Yes.
this link is there, right? Its address I am going to refer to this one.
Okay.
So now this will become your head node. Now what is
Okay.
the first node? 5. How you can identify next node? Next pointer is there, which is pointing to 10. What is the next node? That next pointer is there. So what is the next node? That pointer is there. What is the next node? That pointer. Like that, based on this head only, the complete operations are going to be performed. Got it?
Yes.
Right.
But yeah, but for the head node, if we know the address, then only we can link to the first node, na?
Yeah, that's what I am telling. In the linked list, there will be one pointer will be there. It is always pointing at the first node, that is head.
Yes.
We have this reference only we have. If new node is created, new node reference is there, right? What is the
Yes.
name of that node? New node.
New
So
node.
this name is there, this name is there. Linking is very easy only, right?
Okay.
After linking, what I'm doing, I'm removing this reference. How I can remove? We are not going to remove manually. Simply, if you give that name to the new node, automatically this reference will be gone. Now head is pointing to 10.
10.
Are you getting my point?
Yes.
Yeah, in detail we will discuss later, sir. Just at a top level, try to understand. Okay.
Okay. Thank you.
Right. So I'm writing code for this. What is the code here? Is static void method name is I am taking add first into so SLL single linked list. So I'm giving integer value. This value I have to insert into single linked list. What is the first process? We have to create a new node. So new node is equal to I am taking new node with your given value. Yes, I created a new node. Then what we have to do? We need to check the primary condition. Array, already in this linked list, we have head is there. Suppose if your head is equal to null, then what is the meaning? We don't have any nodes in this linked list. My linked list is empty. Then your head will become new node. Your head will become new node. Then come out from this. No need to stay in that because task completed. Suppose if your head is there, then what we have to do? Your newly created node is there, right? Its next field is pointing to head. Then your head will become new node. That's all. This is the program to perform this particular single link. I mean, to add the object at single linked list. I think this explanation, at least somewhat idea, you got it, sir. Right? Can you please confirm any doubt on this code snippet?
Clear, sir.
Yes, is it clear for you people? Please confirm.
Yes, sir.
Clear.
So that
Yes.
node and new node equal to new node of value, right?
Hmm.
When we give that, can you just give a pictorial representation? It will be like that red color 10, right?
Yes, yes. So whenever you are calling this a new node, it will create a new node like this. So which is having 2 pointers. So this pointer is pointing by data field. So the data field is nothing but whatever value that you have given. Yeah, can you please confirm? Am I audible now?
Yes, sir. Audible.
Yes, sir.
Yeah, somewhat got deleted.
Sir, it's
Yeah, sir,
breaking now.
1 second, please wait.
Okay.
Yeah, please wait. now? Yes, I request everyone to please confirm. Is my voice is clear now?
Yes.
Yes, sir.
Right.
I have one doubt. Like, can you explain that line if head equal to null?
One second, sir. So this node is nothing but which is pointing to the next field. This node is nothing but which is pointing to the next field. Like this we have. Okay. So here someone is asking, sir, if head is equal to null. Consider initially I don't have any nodes. Initially I don't have any nodes. My linked list is empty. So there I am going to create my first node. Let us consider the data is 11 and this node will become what? New node, and the next field is null. Is there any other nodes are there? Is there any linked list in this? No. Then this condition is going to satisfy. So in such cases, this new node is there, right? It will become head. So next time I'm going to create one more. Now this node will become what? New node. So next field is there. So consider the data is 10. Now this is not. Now is the head is there? Yes. Now what we are doing? So this next field is pointing to this one and this will become head node. Like this we are maintaining. Got it?
Sir, I have a doubt.
Hmm.
Sir, here head is a referenced variable, right?
Yes, sir.
Then where you define a head variable in the program?
Sir, this is
Yeah,
a simple code I am explaining, sir. I already told this is not a complete program. This is a small function what we are taking. Head is a reference variable for node class is there. That part we will discuss later. Okay. Node is a inbuilt class. No, we have to define. Sir, please concentrate on the picture. Please concentrate on the top level picture. I am explaining a story for you. That's all. Okay. So don't ask interrelated links. Is the words are correct or not? Just you need to cross check. Someone is asking new node dot next is equal to head. Can you please explain? We will see. New node is nothing but an object. For that next node is head. This is nothing but this link is there, right? This link is established by this statement. Up to that you try to understand. Okay. Clear? Narendra, Nagendra or Narendra? Narendra. Right. Sir, now I want to explain the same process, sir. How you can able to do for adding at ending. Sir, I want to add a node at ending. How you can able to do. For this, I want to demonstrate a logic. So consider I have already some nodes are there. Let us take this is first node and this is the second node and this is the third node and like this I have three nodes are there. Let us take a 10 and then this one is a 20 and this one is a 30. Okay. I want to add one more node at the ending. So this next reference is this one and this next reference is this one, and which will be head node. This is nothing but my head node now as of now. Now I want to create a node at the ending. So what is the task here? What is the task here? I am going to write the title of this program as so single linked list. Single linked list. Sir, what is the operation? So insert node at ending. Insert node at ending. We have to insert the node at ending, sir. I need to write code for this. Anyway, first I will write the code, then I will explain the executable part because it is somewhat difficult. Okay, first I will write the code, then I will explain. Yes, iterate up to end, correct. So what is the function name that I am taking? So static, I am taking static void. So add last into SLL. We have to give value only. That's all. First step is common. We have to create a new node. We have to create a new node with a node of that value. Sir, after this, what we have to do? As usual, we have to check. If head is equal to null, then what will happen? Sir, your head will become new node. Your head will become new node. and then you have to return the control. Just for space adjustment, I am writing here itself. Okay, sir, if head is not equal to null, then what will happen? Then what will happen? You need to move till the ending, sir. You have to move to the till ending. How you can able to do that? Very simple. Node, I am creating some temporary node which is always pointing to head. I am creating a temporary node which is always pointing to the head until while temp dot next is not equal to null. Until you have temporary node not equal to null. Sir, for space convenient purpose, I am writing here. Your temp will become temp dot next. Like this, we have to move up to ending. Sir, after this, what we have to do? We need to take, okay, we need to take, so temp dot next will become new node. We are not required to write. We are not required to write any code for that. I mean, that head pointer is there, right? We are not required to point. Now let us see how it is going to work. I am going to trace. Sir, I am creating a new node in this first step. This is the new node. Sir, next field already here, next field is null. Okay, I created a new node with the content 40. So next field is null. What is the name of this node? This name is nothing but new node. Like this I have. Sir, now I'm taking a pointer. Observe carefully. Is your head is equal to null? No, my head is not equal to null. Then temp is equal to head. This node will become temporary node. What is the condition? Temp tends to next. That means a temporary node next field. Is it not equal to null? Yes, it is not equal. So when it will become null? Here it will become null. Sir, next field is there. Okay, next field is there. So temp is equal to temp tends to next. Temp tends to next is nothing but this node. Now this will become temporary. This reference will be gone. Okay. Now while loop, right? Again it will execute. Is a temporary node next field? This is now temporary. Is its next field is not equal to null? Yes, it is not equal to null. Now temp will become temp tends to next. Like this, we are making this a temporary node to point to the ending. Now, while temp tends to next is not equal to null. No, here a temp tends to next is equal to null. This while loop is going to fail. Now it will execute temp dot next. It is null. Now this reference is pointing to new node. This is the new node, right? Like this we have. So is there any requirement to change head pointer? No, because we are inserting the node at ending. We are not required to change head pointer because already head pointer is pointing at the beginning only. Okay, like this we can insert the node in the single linked list at the ending. I think you people got a clarity about this. Any doubts, friends?
Sir,
Hmm.
what about temp variable after we are setting it to the last node? Will we destroy it or it will be there only?
Yeah, it will be destroyed automatically because these are local variables. So within this function I am defining, right? So where I am defining that temporary within this function. So once
Yes.
if the function execution completed, those variables by default eligible for garbage collector.
But sir, temp is not equal to null, no?
Hmm.
Temp variable is not equal to null, right?
Even though it is reference variables, right? Sir, we are not writing this code in the class. We are writing in the function. In the function, whatever variable you are taking, is it possible to access outside?
No.
No,
Yes,
then it is local variable. Local variables, we are not going to concentrate more on memory related issues because these will be available in the live when we are executing that function. Once if the function execution got completed, it will be default gone. Clear? See,
yes, sir.
the only variable what we have permanent variable is head, except that remaining all are temporary only. Even that new node we are creating, and once if this link got established, so this reference also will be gone. So this link is established so that this data is safe. If you want to get this data, ask the head. Array, I want 40. So then head will check. Is my data is 40? No. Next. Is the next node data is 40? No. Is the next node data is 40? No. Is next node data is 40? Yes. So this is called a searching operation. It will do. Got it?
Yes. So every time we will call this function, only one temp variable will get created. So there is no need to
Yes.
bother about it.
Yes. Sir, I request everyone to please respond. Try to concentrate on outline. Is it clear for you people? Right. So this is nothing but how you can able to add the value. Just this diagram I'm going to upload in the running notes. Don't worry. So next, so maybe you people got very confusion. That's why tomorrow we will see how you can calculate. Okay, tomorrow we will see how we can calculate sum of n natural numbers implementation, and even I am going to explain factorial of the given number implementation. Then same style, how to traverse the single linked list, how to reverse a stack. These two operations I will explain tomorrow along with these two codes. Okay, so that's all about today's session. I request everyone to please register as early as possible. Okay, so from tomorrow, tomorrow is the last demo session. From Friday, we will have our regular classes. Okay, right, sir. Thank you. We will meet for the continuation tomorrow. Any doubts?
One question.
So today this was just for a demo purpose, right? So
Yeah, these are demo.
in detail for this single link list, because in the
Yeah,
second,
sir. This linked list is just a sample code I explained. That's all.
yeah,
So because you need to
I
understand
tell,
how, yeah, you
I
need to
don't.
understand how my flow of execution will be there. Is it possible for you to understand my teaching or not? That is the meaning of demo classes, right?
Yeah.
Yeah, that's what I am trying to explain, how I am going to explain this with the help of diagram. I think you can see at the outline, it is clear, right?
Yes.
So internally, how this structure, all these things, we will see one by one. In the linked list, that's what I told. Around some 3 hours, 4 hours, purely we are going to spend on single linked list, so that you can understand each and every line clearly with the help of diagrams and code. Okay.
Yes.
So these running notes and
Yeah,
videos,
these
sir.
running notes and videos, as of now, it is there in my hand. But once, if the regular classes started, at a time, we will give for each and every student. Okay.
I mean, it will be. I already registered, sir. So.
Oh, okay, no problem, no problem.
So,
You will get it from
Friday.
Friday class. In the Friday class, I am going to give running notes access. Friday evening, admin people are going to give videos access.
Okay.
So one
Right,
question, sir.
this yeah, I mean on outline I got to know what you explained, but node, I think there would be a class of node. I think all will be detailed. Node class.
Yes. If you want, just 1 second, sir. I will show you.
I think that is not the predefined class. I think that
Yeah,
is not
it is user-defined class, sir.
user defined. Okay.
I'm going to create that one.
Okay.
I will show you. Here you can see on my screen.
Okay.
Have you observed?
Yes.
Class node is there, which is having data field and then next field. Now we created a new node, right? In the diagram, we created a new node just by passing the value. So what will happen? The current node data will become data. Next field is pointing to null. Size plus means what? Whenever a new node got created, that size will be incremented to know how many elements are there in the linked list. Okay. And here you can see add first. The code, whatever I have written, same code. Add last, like this. So these are functions. So now if you see the main method, how I am going to run the main method, maybe I have not mentioned here. Where is main method? I think
in the main method you have to pass a value, then automatically from the reference taking the class, one object will be created, and from the object it will transfer on the main logic you have showed us.
Yes. 1 second. I will show you the main method, because yeah, you can see here. So single linked list, I created one object, add last. It will create a new node automatically.
Yes.
So add last, it will add always at last. Got it?
Yes.
Don't worry, every functionality I will explain.
Yes. Thank you.
Right.
So one question, sir.
Please.
Sir, in Java, we have already data structure backed concept that is collection. Okay, sir. So then why we need to know other than that, like this, we have to know all this.
Sir, those are predefined, right?
Yes,
So
sir.
our main intention of data structures class is nothing but what. So what is a data structure? How we can able to create a data structure? That is our main agenda. Even though we have predefined concept, we are going to explain how that is implemented, all these things. Okay. So suppose if tomorrow a new data structure you want to implement, so you are not required to depend on already existing, because this is a learning phase, right? So if already these collections are there, what is the need to explain by myself this data structure? No need, right?
Yes.
So internally how it is working, how it is implemented, to know that we are doing investigation on that. But when the real-time project come, then you have to depend on your data. We will use predefined concepts there. Got it?
Yes, sir. Thank you.
For example, consider, of course, we have what you can call generics also there. What type of data you want to push, you can push. Everything is there in the predefined. But how internally those things are implemented, we are going to discuss. Got it?
Yes, sir.
Right. Okay, sir, fine. Tomorrow we will meet for the continuation for this. Thank you.
Thank you.
Thank you, sir.
Thank
Thank you, sir.
Thank you.
Right.